What is the maximum number of emission lines when the excited electron of a hydrogen atom in n is equal to 6 drops to the ground state? This becomes interesting. What does it mean? See, all they're saying is some electrons are present in n is equal to 6. From 6, I have 5, 4, 3, 2 and 1. The maximum number of emission lines means how many different frequencies or wavelengths can be observed. So, a hydrogen atom. So, first of all, please remember, you have only single hydrogen atom, you don't have many. Okay. So, what are the ways in which electron can fall back? Well, from n is equal to 6, straight it could have fallen back. From 6 to 1. And in that case, you would have said that there is a single photon. So the answer would have been 1. But is it the maximum number? No. The maximum would be 6 to 5, 5 to 4, 4 to 3, 3 to 2, 2 to 1. So 1, 2, 3, 4, 5. So 5 photons, if they are emitted, that is the maximum possible number of emission lines you might possibly observe. I am talking about a single hydrogen atom because that is what has been asked. So what is the maximum number of emission lines when the excited electron of this is the keyword here, of a hydrogen atom in n barabar 6 drops to the ground state? This, my dears, is the answer. 5 different photons are possible. The first photon would be emitted from 6 to 5, then from 5 to 4, second photon, 4 to 3, third photon, 3 to 2, fourth photon, and 2 to 1 would be the fifth photon, one after the other. That is the possibility. Also, there is a beautiful way to get it wrong. What? If you neglect this word A, and you would see that in a number of possible popular internet solutions. If you neglect the word A, that means if you assume that there are many hydrogen atoms, if there are many hydrogen atoms, then you could have one hydrogen atom in which this is happening. I could have had another one in which there is a direct emission. And please note, this photon is different from any of these 5. Yes. Are there not more possibilities? There are many more possibilities actually. Can we count them? Let me help you in counting them. Let me repeat and stress first. The solution to this question is over. The answer is 5. But across the internet, you might find the answer is 15. How do I know this? I know this. Everybody knows this. And why this? I'll tell you how they get 15, why it is wrong. But I've already told. Single hydrogen atom can just give you this much. If you have more than one, in one of the hydrogen atoms this is happening. In the second one this may happen. In the third one, yes, there is a different possibility. What? I could have this and then this. Oh my God. So what do I get? I get 2 photons here. Then this is also combination possible. This and this. And then this and this. What nonsense is this? How can you count? See, it's very simple. Mathematically, from n is equal to 6, you could go to 5, 4, 3, 2, 1 directly. So there are 1, 2, 3, 4, 5. 5 photons possible. That is 1. If you're jumping directly from 6 to any orbit, you can get 5 different photons. Okay. Now, from n is equal to 5, if you're again falling down, from 5 you could come to 4, 3, 2, or 1. And please note, this has nothing in common with this. If you're counting like this, this is same. It becomes problematic. Okay, so you have to, you have to make sure that you're not counting double. But this method which I'm teaching you, you would see that there is no possibility of counting double because in this case you started with n is equal to 6. And in this case, you're starting with n is equal to 5. And 5 is directly going to 4 or 5 to 3 or 5 to 2 or 5 to 1. So there are 4 photons possible. Right? And then n is equal to 4, 3 and 2. From 2 you can go to 1. From 3 you could go to 2 or you could go to 1. From 4 you could go to, well, 3 or 2 or 1. So you have 5 photons or 4 or 3 or 2 or 1. So 1 plus 2 plus 3 plus 4 plus 5. Well, you add them up and you get how much? 15 photons. Is this the answer? No, this is not the answer. This is the answer given on internet. Popular other edtech sites, etc., the rubbish ones. Why I'm telling you this? So that you don't get confused. Oh my God, there are 10 people offering 15 as the answer, and maybe sir didn't know. I know this very well. The only thing is, you should know this is a tricky question. If you have a single hydrogen atom, answer is 5. If you have a sample of hydrogen atoms which has multiple hydrogen atoms, then my dears, the answer would be 15. Can we have a mathematical formula? You can. How exactly? Just clean up the space and write that for you. You can do direct counting like we have done, common sense. But common sense is again a dangerous and a rarer sense. So, can you do it as a formula also? Oh, yes. There are cheap guides which mention formula, and we love that cheapness and brainlessness. So please give us a formula. We can directly calculate. Well, we can do that. How? I'll tell you. I told you a method, now I'll tell you a formula also. If you have n shells, you take any 2 at a time, NC2. Okay, and you get that. That's it. Okay, and how much is NC2? NC2 is, why? Because out of n shells, you take any 2 at a time and exchange the photon between them. And this is a unique photon you will get. This is n factorial by 2 factorial into n minus 2 factorial, which is n into n minus 1 upon 2. Okay. So does this formula fit here? Yes. If n is equal to 6, then 6 into 6 minus 1 upon 2, which is 3 into 5, which is 15. See, we get this. So what is this? Maximum number of photons possible in the spectrum. And spectrum is obtained only when you have multiple atoms. I repeat, I really repeat for a 5th, 6th, 7th time. A hydrogen atom, if this is only a single hydrogen atom, the answer cannot be more than 5. If you have a group of atoms, then you can have the answer as 15.